Welcome back to the deep dive. Those AI programs that write poems or compose music or even create those like photorealistic images,
Hmm.
well, that's generative AI. And you asked
Hmm.
what programming language makes all that magic happen?
Right.
Well, uh, get ready for a fascinating journey because it's not a one language show.
It's a bit like building a house.
Yeah.
You wouldn't use a hammer for everything.
Right.
You need saws, drills, screwdrivers,
Yeah.
different tools for different jobs.
Yeah.
Generative AI is similar. Each language has its strengths, making it the perfect fit for specific tasks.
Okay, so our source material dives deep into the most popular languages for generative AI, almost like a cheat sheet for understanding the tools of this rapidly evolving field. And we're starting with Python, the undisputed rock star in the world of AI. What makes Python so special for generative AI? Is it just because it's trendy?
It's definitely popular, but
Mhm.
for good reason.
Mhm.
Python's known for its readable syntax, which is like plain English for
Yeah.
computers. This readability is key for generative AI because it allows developers to quickly prototype and test ideas without getting bogged down in complex code. Imagine sketching out a design before building the actual structure. Python allows for that kind of agile development in AI.
So it's less about the language itself and more about the speed and flexibility it offers.
Exactly. Python also boasts a treasure trove of libraries. TensorFlow, PyTorch, you name it, pre-built tools specifically for AI and machine learning. Think of them as specialized workshops packed with instruments for crafting intricate AI models.
Wow.
For example, TensorFlow is fantastic for building those deep learning models that power many generative AI applications, while PyTorch is known for its flexibility, making it a favorite among researchers pushing the boundaries of AI.
It sounds like Python provides both the foundation and the specialized tools to build almost anything in generative AI. The article even mentions GPL-3, that mind-blowing language model that writes text so human-like. It's almost spooky. It's a
Yeah.
Python creation, right?
It is. GPT-3 showcases Python's power in handling complex tasks, like natural language processing. So if you've ever been amazed by an AI writing a song or poem,
Yeah,
chances are Python was behind the scenes orchestrating the whole thing.
that's incredible. But hold on, the article also mentions that Python has a bit of an Achilles heel. Its speed. Is that right?
That's true. Python's an interpreted language, which means it's executed line by line, making it a bit slower than compiled languages, especially when running large, complex models. It's like reading a recipe step by step
Okay.
versus having the entire meal prepped and ready to go.
Right.
So while Python is perfect for the initial design and build, if you need raw processing power for massive data sets, you might consider a different tool for the job.
So it's all about choosing the right tool for the job. Speaking of different tools, the article then jumps into JavaScript, the language that brings AI right to our fingertips in our web browsers. What's the key advantage here?
With JavaScript and frameworks like TensorFlow.js, AI models can run directly in your browser, making them instantly accessible. No installations, no downloads. It's like having an AI studio built right into your webpage. This accessibility opens up amazing possibilities for interactive AI experiences.
That instant access factor is super cool. The article mentions StyleGAN as an example.
Yeah.
This AI can create incredibly realistic images and artwork right in your browser, thanks to JavaScript.
Mm-hmm.
Can you paint a picture of what that looks like in the real world?
Imagine visiting an online art platform. Instead of browsing through pre-existing images, you could interact with a StyleGAN model, tweaking parameters and generating unique pieces of art in real time. It's like having a personalized AI art studio at your fingertips. JavaScript makes this level of interactivity possible.
It's like having an AI artist collaborating with you on a project, which is amazing. It feels like we're just scratching the surface of what's possible with generative AI on the web. But even with all this flexibility, I'm guessing JavaScript has its limitations too, right?
Of course. While JavaScript excels at bringing AI to the web and creating interactive experiences, it's not typically used for training those massive resource-intensive AI models.
Okay.
It's more about implementing and running models that have already been trained elsewhere, often using more powerful languages. And while the JavaScript AI ecosystem is growing rapidly, it's still not as mature as Python's, which might mean fewer readily available resources if you get stuck.
So JavaScript is the go-to for making AI interactive and accessible on the web, but maybe not for creating the next GPT-3. Makes sense. Now let's shift gears to a language that sounds more like it belongs in the corporate world, Java. It's known for being robust and reliable, almost like the backbone of large-scale systems. Why is Java favored in enterprise settings, particularly for generative AI?
You hit the nail on the head. Java has a long-standing reputation for stability and security, which are paramount when building large-scale mission-critical applications, especially in sectors like finance or healthcare, where data integrity is essential. Think of it as the bedrock upon which you can construct intricate and reliable AI systems.
The article mentions Java being used to create generative models that simulate financial scenarios.
Yeah.
This is fascinating because it shows how generative AI can be used not just to create something new, but also to understand and model complex systems, right?
Absolutely. Imagine a financial institution wanting to predict market fluctuations or assess risk. By creating generative models that simulate various market conditions, they can make more informed decisions and manage potential risks effectively. Java's ability to handle massive data sets and integrate seamlessly with existing financial systems makes it a perfect fit for these applications.
It's almost like creating a virtual sandbox to test different financial strategies and predict outcomes, all thanks to Java and generative AI. It's a great example of how this technology is quietly impacting our lives in profound ways. But let's be honest, Java's not exactly known for being beginner-friendly, is it?
That's true. While Java is a workhorse in the enterprise world, it's not the easiest language to learn. Its syntax can be complex, and it requires a deeper understanding of programming concepts. It's like mastering a powerful tool. It takes time and effort, but the results can be incredibly rewarding.
So while Java is a heavy hitter in enterprise-level generative AI, Python might be a better starting point for those just beginning their AI journey. Right, we've covered Python, the versatile all-rounder, JavaScript, the web wizard, and Java, the enterprise champion. Now, let's explore a language that's all about data. It's a powerhouse in the world of statistics and data visualization. So where does R fit into the generative AI landscape?
R excels in the research-heavy areas of generative AI, especially when dealing with massive data sets and intricate statistical analysis. One of its key strengths is creating synthetic data sets.
Now, hold on a second. Why would you want to create fake data? Isn't the whole point of AI to work with real-world information?
That's a great question. Imagine working with sensitive data in healthcare, for instance. Using real patient data for research can raise significant privacy concerns. Synthetic data sets created using R and generative AI can mimic the statistical properties of real data without containing any personally identifiable information. It's like creating a statistically accurate replica of the real data set, but with complete anonymity, allowing researchers to explore and analyze patterns without any ethical dilemmas.
So it's like having a statistically sound stand-in for real data, which is brilliant.
Right.
The article even mentions R being used in medical research, particularly in situations where real data might be scarce or difficult to obtain. Can you give us an example of that?
Absolutely. Let's say researchers are studying a rare disease and there's limited patient data available. Using R and generative AI, they can create synthetic data sets that expand the pool of data, allowing for more robust analysis and potentially leading to better diagnostic tools or treatments.
It's incredible how generative AI can be used to address such critical challenges. And R seems to be the tool of choice for data-driven researchers. But I'm guessing R has its limitations too, right?
Of course, while R is a master of data manipulation and statistical analysis, it's not known for its speed. It's generally slower than compiled languages like C++ when it comes to executing complex calculations. And the RAI community, while growing steadily, is still smaller than Python's, which could mean fewer readily available resources or support forums.
So R is the go-to language for those comfortable swimming in a sea of data, especially those working in research or data-heavy fields. However, if speed is a top priority, there might be better alternatives. Speaking of speed, let's talk about C++, though. This language is all about performance and efficiency, right? It's like the Formula One race car of programming languages.
That's a great analogy. C++ is known for its raw speed and its ability to control hardware at a very granular level. It's a compiled language, which means it's converted into machine code all at once, making it incredibly efficient, especially for real-time applications where every millisecond counts.
The article mentions its use in game development specifically for creating those immersive environments and realistic character behaviors. Can you give us a peek behind the curtain and explain what makes C++ so valuable in gaming?
Imagine playing a game where the world around you isn't pre-designed, but generated in real time as you explore.
Wow.
That's procedural terrain generation, and C++'s speed makes it possible. It can churn through complex calculations, creating vast landscapes, intricate details, and even dynamic weather patterns on the fly, all without causing those dreaded lags or glitches.
It's mind-blowing to think that C++ is working behind the scenes, crafting those stunning landscapes and lifelike character movements that make our gaming experiences so immersive. But let's be real, learning C++ is not exactly a walk in the park, is it?
You're right. While C++ unlocks incredible performance, it's also known for its steep learning curve. Its syntax can be complex, and it often requires a deeper understanding of computer science concepts, especially memory management and low-level programming. It's definitely a language that rewards dedication and persistence.
So while C++ might be the language of choice for speed demons and those seeking ultimate control over their code, it's probably not the first one you'd recommend to someone just dipping their toes into the AI waters. All right, we've covered quite a bit of ground exploring the giants of generative AI programming, Python, JavaScript, Java, R, and C++ way. But the world of programming is constantly evolving, and our source material hints at some emerging languages that are making their mark in the AI space. Can you give us a quick overview of these rising stars?
Of course, we're seeing languages like Swift, Julia, and Rust gaining traction in generative AI. Swift, for example, is becoming increasingly popular among developers building AI features into iOS apps, thanks to its speed and integration with Apple's ecosystem.
So Swift is riding the Apple wave and making AI more accessible on our iPhones and iPads. What about Julia?
Julia is known for its blazing fast performance, especially when handling complex mathematical operations, making it attractive for research-heavy AI projects that demand computational muscle.
It sounds like Julia is stepping into the ring, ready to challenge Python for the title of AI speed champion. And what about Rust? Where does it fit in?
Rust is gaining recognition for its focus on safety and reliability. It's designed to prevent common programming errors that can lead to crashes or security vulnerabilities, making it a strong contender for AI systems where reliability and security are paramount.
It seems like the world of generative AI programming is constantly evolving, with new languages and tools emerging to meet the demands of this rapidly growing field.
Right.
It's both exciting and a bit overwhelming to think about all the possibilities. But before we get ahead of ourselves, let's take a step back and see how these languages are being applied in real-world scenarios. Our source material highlights three case studies: ChatGPT, Artify, and a fascinating project in finance. Yeah, let's dive into those after a quick break. Welcome back. We just explored that diverse landscape of programming languages used in generative AI, and now it's time to get down to like brass tacks and see how these languages are actually being used in real-world projects. The first case study features ChatGPT, the AI chatbot that's taken the world by storm. It feels like ChatGPT can answer any question, write any type of content, and even hold a decent conversation. I'm curious what language was used to build this impressive AI.
ChatGPT, developed by OpenAI, was built using Python. It's a prime example of how Python's extensive libraries and APIs, especially those focused on natural language processing, can be used to create a sophisticated generative model capable of understanding and responding to human language in a remarkably human-like way.
So Python's not just about generating text, it's about making AI understand and interact with us in a way that feels natural and almost intuitive. It's incredible to think about all the potential applications of this technology. What about the second case study? It focuses on an art generation platform called Artify, right?
That's right. Artify is a UK-based startup that created a platform for generating unique artwork using generative AI. What's particularly interesting about Artify is their choice of JavaScript and TensorFlow.js to build their platform.
Okay.
This allows users to interact with the AI model directly in their web browsers, creating art in real time without any downloads or installations.
That's the power of JavaScript. It makes AI instantly accessible to anyone with an internet connection. You can literally visit their website and start creating art with AI, which is amazing. It democratizes access to this technology in a way that's truly remarkable. Okay, last but not least, let's talk about the third case study, the one in finance.
This case study revolves around a financial institution in London that used Java to build a generative AI model for simulating financial data.
Okay.
Their goal was to use this synthetic data to assess risk and analyze market trends, essentially creating a virtual testing ground for financial strategies.
It's like building a virtual financial simulator powered by AI. It's a great example of how generative AI can be used to understand and model complex systems, not just to create new content. Why did this institution choose Java for this critical project?
Java's reputation for reliability, security, and its ability to integrate seamlessly with existing financial systems made it a natural choice for this application.
Hmm.
They needed a language that could handle massive data sets, perform complex calculations reliably, and interface with their current infrastructure, and Java fit the bill perfectly.
It's amazing how each language has its own set of strengths, making it the perfect fit for specific applications. So we've got Python powering a conversational AI that can write and understand human language, JavaScript bringing AI-powered art creation to our web browsers, and Java driving financial simulations that help manage risk and predict market trends. These case studies really highlight how generative AI is impacting diverse fields in remarkable ways.
They really do. These real-world examples illustrate that there's no one-size-fits-all best language for generative AI. The choice depends entirely on the specific application, its requirements, and the desired outcome.
It's like having a toolbox full of specialized tools. You wouldn't use a hammer to tighten a screw right.
Right.
You need to choose the right tool for the job. And the same principle applies to selecting a programming language for a generative AI project.
That's a fantastic analogy. And just as a skilled craftsperson knows which tool to use for each task, a seasoned AI developer understands which programming language will yield the best results for a specific generative AI project.
All right, so we've explored the popular languages used in generative AI, delved into their strengths and weaknesses, and even witnessed their real-world applications. Now let's shift our focus to someone who's just starting their journey into this fascinating world. If someone wants to learn more about generative AI, maybe even try building something themselves, where should they begin?
Well, first of all, it's important to remember that generative AI is a vast and rapidly evolving field. There's always something new to learn and discover, so don't feel overwhelmed if it seems daunting at first.
It's a journey, not a race, right?
Exactly. It's about exploration and discovery, and thankfully there are tons of resources available to guide you along the way. There are online courses, tutorials, communities, and even open source projects that can help you get started.
So it's all about diving in and exploring. If we were to give one piece of advice to someone starting their generative AI adventure, what would it be? Which language would you recommend as a starting point?
I would say start with Python. It's the most accessible language with the largest community and the widest range of tools and libraries, specifically for AI and machine learning.
It sounds like Python is the perfect gateway to the exciting world of generative AI. Once you've grasped the fundamentals and gained some confidence, you can branch out and explore other languages like JavaScript for web-based projects or Java for those enterprise-level applications. It's all about finding what sparks your interest and building from there.
Absolutely. And don't be afraid to experiment. Try building small projects, join online communities, and share your work with others. The more you immerse yourself in the world of generative AI, the more you'll discover its endless possibilities.
Learning by doing is always the best approach, especially in a field as dynamic as AI. Now, you mentioned that choosing the right language depends on the specific application, and the article talks about considering factors like application requirements, performance needs, and community support. Can you elaborate on those a bit more? What kind of questions should someone ask themselves when choosing a language for their generative AI project?
Great question. It's all about understanding the scope and goals of your project. First, consider the environment where your application will run. If you're building a web application, JavaScript is likely your best bet. Its integration with web browsers and the ability to run AI models directly in the browser make it ideal for creating interactive and accessible AI experiences.
Makes perfect sense. So if your goal is to bring AI to the web, JavaScript is your go-to language. What about performance? If speed is crucial, which language comes out on top?
Well, as we discussed earlier, C++ reigns supreme when it comes to performance in generative AI. If you need lightning-fast processing for real-time applications like video game development, high-frequency trading, or anything that demands those split-second responses, C++ might be the right tool for the job.
So we've got JavaScript for the web and C++ for speed. What about that last factor? Community and library support. Why is that so crucial, especially for someone just starting out?
When you're working with complex technologies like AI, having a strong community to turn to for help and advice is invaluable. It's like having a network of experienced guides and mentors who can help you navigate the challenges and complexities of building AI systems. And having access to a wide range of libraries and tools can save you countless hours of work and frustration. It's like having a well-stocked workshop with all the specialized tools you need to bring your AI creations to life.
It's like having a support system and a treasure trove of resources all rolled into one. So Python, with its massive and active community and its extensive library ecosystem, would be a great choice for beginners who might need that extra guidance and support along the way.
Exactly. Python's community is known for being welcoming and helpful, which can make the learning process much smoother and less intimidating.
Okay, so we've covered an incredible amount of ground today, exploring the key programming languages that drive generative AI, from Python's versatility to JavaScript's web prowess, Java's enterprise strength, R's data mastery, and C++'s raw speed. We've even delved into real-world applications and offered guidance for those just starting their AI journey.
It's been a fascinating exploration, and I hope our listeners are feeling inspired to delve deeper into this incredible world of generative AI.
Me too. And as we wrap up this episode, we encourage you to keep in mind that the world of generative AI is constantly evolving. Stay curious, keep exploring, and never stop learning. Until next time, keep diving deep. It's like we've explored this incredible toolbox filled with powerful instruments, and now it's time to think about how we use these tools responsibly and ethically.
That's a great analogy. It's not enough to simply marvel at the technical capabilities of generative AI. We need to consider its potential impact on society, the workforce, and even our understanding of creativity and originality.
It raises so many interesting questions. For example, if AI can create art that's indistinguishable from human-created art, what does that mean for the role of artists in society? And if AI can write code compose music and even write news articles, what implications does that have for jobs and the future of work?
These are complex questions with no easy answers. It's a reminder that technology is not neutral. It's shaped by the people who create it and the values they embed in it. As generative AI becomes more pervasive, it's crucial to engage in open and honest discussions about its potential benefits and risks, and to develop guidelines and regulations that ensure its responsible development and use.
It's like having a powerful new medicine with the potential to cure diseases, but also the potential for harmful side effects if not used responsibly. We need to approach generative AI with a similar level of caution and foresight, weighing its benefits against its potential risks.
Exactly. It's about finding that balance between innovation and responsibility. We need to ensure that generative AI is used to empower people, not replace them, to enhance creativity, not stifle it, and to address societal challenges, not exacerbate them.
It's a call to action for everyone involved in the development and deployment of generative AI, from researchers and engineers to policymakers and the general public. We all have a role to play in shaping the future of this technology.
Absolutely. It requires collaboration across disciplines, bringing together diverse perspectives to ensure that generative AI is developed and used in a way that benefits humanity as a whole.
So, to our listeners, the next time you encounter a stunning piece of AI-generated art, a catchy song composed by an algorithm, or a news article written by a bot, we encourage you to think beyond the wow factor and consider the broader implications of this technology.
It's about becoming informed and engaged citizens in a world increasingly shaped by AI. Ask questions, challenge assumptions, and be part of the conversation about how we want to live with and alongside these powerful technologies.
It's about recognizing that we're not just passive consumers of AI. We have the power to shape its future and ensure that it aligns with our values and aspirations.
And that starts with understanding the tools that make it all possible, which is what we've explored in this deep dive into the world of generative AI and the programming languages that drive its creation.
Well said. And on that note, we've reached the end of our deep dive. We hope this exploration has sparked your curiosity and inspired you to delve deeper into this fascinating and rapidly evolving field.
It's been a pleasure exploring these ideas with you, and we look forward to diving into new topics with you on our next episode.
Until then, stay curious, keep exploring, and as always, keep diving deep.